for using this equation, duration is equal to means plus the x times with standard deviation. So this will be using the normal distribution table, which in the next 2 pages, right? So we have this duration. We define this duration over here is called probability at which the calculated duration will be happen. So that is something is very hard to understand is why we have the probability over here. That is because if we look at the durations in this simple project here, you see the duration is not always a fixed number as a 20. The duration is a changeable number. It varies between 14 is the smallest one and the 25 is the largest one, right? So that means if we can do something over here is like you have this sense here, and then you have 14 here, and you have 17 something here, and you have 27. 27 is the largest one, thanks. And the 25 and the 23. So you have something, if you're putting some together, you will show this statistic. We call this called history plot, right? And then you will see this is a distribution. If you learn about the statistics, you know this is a distribution. And we have the mean over here, right? So that is the normal distribution plot. We have the mean in the middle, and then we have something larger than this mean or less than this mean, to both sides, right? And we have this one over here is called the distribution, right? And we know less than the mean is 15%, and more than this mean is another 15%. So everything underneath this red bar is the red curve, right? Is one or 100 percentages, right? So that is the probability we're going to see. Okay, so once you understanding those normal distribution plot over here, and we can get in those more detailed things from the table, right? So the probability here is going to see in which of the confidence, right? You will see your duration is within this range or without that range. So come to here, see, we have our mean here is 20, and how many percentages your duration is more than 20. So that is half percent, half of one is 15% is more than this mean, right? And then you have another half chance, see your any of those durations is less than this mean, right? So by putting the two together is one, right? So that means we have this. So the one is equal to the probability of less than the mean plus the probability of more than the mean. Is that equation make sense to you? The one here we call 100 percentages, right? So this is 15 percentages, and this is another 15 percentages, right? So this is this half, and that is this half, or even how you use in green. Okay, so that is why we have this distribution plot here, and also when we're going back to see the table, you will see more detail about it. Okay, now let's go to the table with those enough information here. So as for this table, you see this one again. So that means this I'm shading with the green here is 15 percentages, right? I'm shading with those blue here is another 15 percentages, right? So, but if I'm shading those as red here, or even how I can highlight with those red over here. How much is those? How much is those percentages? So graphically, it looks like it's 30. It's not 30, it's more than 30. Right? Graphically, it looks like this is It's kind of like the 70 something, right? So, but how to get is more correctly. So this is more than 15 because this part is 15. And this part is another x. So we are not understanding this. And this part is another 1 minus 15 minus x. So the x over here is not this x. This is x percentages. The x over here is the number of the standard deviation to the right of the mean. So don't be confused with this x. I'm going to remove this one. So this x in this table over here is the number of the standard deviation to the right of the mean. That is means it's how many times x times more than the mean. And the x times what is the standard deviation. So that is means if you have a mean is equal to 7, and you have your standard deviation is equal to 2. And if you have a duration is 9, right? And then you're using the duration minus with your mean divided by your standard deviation. So this will be giving you 9 minus 7 divided by 2 will be equal to 1. And this 1 is the x. Okay? So it's the number of the standard deviation to the right of the mean. To the right of the mean is more than the mean. More than the mean using duration minus the duration, minus the duration of the mean durations, right? And then you get that difference. How many percentage, right? And divided by the standard deviation, you get this x. So this x is not the number different to the mean. It's the difference divided by the standard deviation. Does that make sense? Okay, so if you're understanding that x is the numbers or the times difference from the mean and your duration and divided by the standard deviation, then you will be easy to get in this one. Okay, so the x is always be calculated as duration minus the mean divided by standard deviation. Okay, so if you're looking for that, you will be okay. Remember this equation is very important. Let me write this one again. So the x is equal to your duration minus your mean divided by your standard deviation. Okay? So same as from this one. So minus this mean and divided by this, you get x. So this is the equation most time we are using this one, and sometimes we are using this one. Does that make sense? So this is for a given idea, and you are using it to determine the duration. And for this is for a given duration, you are going to determine the probability or how many percentages that will be, or how many confidence you will have this be happen. So this is the standard equation, and this is the second alternative equation you're going to use in this in the following slides with the examples. All right, so now we're taking a look at how we using those table. So in this table, this x is determined by two things. So this column over here, you will see 0.0, 0.1, 0.2. Those are the first decimal place for the x. And then this 1, 2, 3 is the second decimal place of this x. So that means you will get x is equal to a number from here and then a number from here. Does that make sense? So that means if we have an x is equal to 0.11, then the corresponding value will become to here. Does that make sense? So that means if your x here is equal to 0.11, that means you are 0.11 times of the standard deviation to the right of your mean. This probability happening, I mean this pink shaded area is 54.38 percentages. In other means this is 54 percentages, 54.38 percentages, right? Is that correct? So then you minus these 15 percentages and you are getting this part is 4.38 percentages. Does that make sense? So you can know this part is that. That is what x refer to, okay? So if you're getting the x here is 0, 0, what that means? So remember, x equal to 0, 0 is means your x equal to 0.0. So that exactly the duration is your mean. So if you come to see here, this is your mean. And then to the right of your mean, the x is equal to 0, right? And then this part, you're always looking from this part. This is 0. And this one is close to 1, okay? So this is your percentage 0, and this is your percentage 100, right? If you have it from the left to the right. So if your x is equal to 0, that means you are getting the mean here. I'm using blue here, you are at the mean here, and then this part is, I'm blue shaded, this part is half of it, right? 15 percentages, right? So those number are the probability, okay? Those number are the probability, and the x is determined by those. So for a given x, you're going to determine the probability. Does that make sense? Using the table. So the table do have a second pages. And when you see the second pages, you will see the x is equal to 3.9. So if x is equal to 3.9, right? So that means to the right of your means with 3.9 times of your standard deviation, and then you will see your probability is equal to almost 100 percentages, right? Here is almost 100 percentages. Then you have your table is looks like, so here is your mean and almost here. Does that make sense? And this is your x, okay? So since you're understanding this, x is important. X can be used to determine the probability. And also in the changeable way, if you know the probability, which one is in the table, then you can going to determine the x. Does that make sense? So you can exchange them, right? And you can interpret them. So since you understand this, we're going to see some the examples, okay? Let's do some examples. So let's see, the first question we have here is, clear? Okay. So activity has been estimated to take an average of 22 days. So the 22 is the mean, right? So you can get your mean is 22. Your mean is 22 days. And then you have your standard deviation. Your standard deviation is how many? 3.5 days, right? And what is the estimated duration if there is to be a 90% confidence that the duration will not be excited. Will not be excited is your duration is less than a number. Does that make sense? Your duration will not excited is the duration will not more than this number. So refer to the plot we have. So when you're doing the question, please make sure you have the plot, okay? So you have your plot like this. You have your mean is 22, and you're going to find a day, the duration will not be more than this 19 percentages. So we know how many percentage is this shaded part? 50, right? And this shaded part is another 50, right? And we know this part is less than 22, and we know this part is more than 22, right? So that means if we want to get in how many we need to have, if we want to get in 90 percentages, right? So duration will not be 19 percentages. This is your property. That means we probably be something like here. Does that make sense? I mean purple over here and ended by this yellow bar, right? And this is the X. So we're going to find X. Does that make sense? So we know this part from the left side of this one beginning infinity to this bar over here is 19 percentages, right? And is that the same as this table here? Is same as this table here? Okay, if it's the same as this table here, then you can get in the data from this table, right? But we can see for here is 18.8 percentages. Is that correct? This is not 19 percentages, right? We're going to find a 19 percentages. Is that correct? So then we're going to the next page, right? Did you guys find where's the 90 percentages? Where is it? Is it here? Is that one 19 percentages? No. That is the most closed one, right? Is that one close or this one close? Which one close? 18,997 is close, right? I don't want you to take additional accurate calculation for this one, just finding the closed one, okay? Just finding the closed one, then we're getting this 18,997 is a closed one. This is your percentages, right? And then your X will be 1.20. Yes. So you get your X is equal to 1.28. Does that make sense? So from the table, refer those property data because it shows as 0. something, but it's 19 percentage something, right? So you will get X is equal to 1.28 from the table. You can call normal distribution table. Does that make sense? From 1.28 from the normal distribution table, once you determine the X, then you have your duration is equal to your mean plus X times with the standard deviation. Is that correct? And then you get a 22 plus 1.28 times with what? 3.5. Does that make sense? Then you get your duration is equal to how many days? Give me a number. $26.48. Is that correct? Yeah. And then don't forget to correct. Okay, so then you get a 27 days. Is that correct? Okay, now you can answer this question. So activity has been estimated to be blah, 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 blah. What's the estimate duration? This estimate duration is 27 days. There is to be 19% that the confidence that duration will not exceed it. But since we round up it because we want to using this one for the CPM calculations, right? But the accurate day is this one, right? This will be here, and this one will be 26.48 here, and those sense the probability will be 19%. Does that make sense now? So within the example here, within more data here, you understanding what we're going to do with that, right? Why we need to have this table and how to find the X based on your probability, and then how to find your durations based on the equation here, right? Take 1 or 2 minutes to finish your notes, and then we move into the next question, okay? Yeah, that's the close one.
What is that from the normal distribution?
Say that again.
What does it say right now? From the normal distribution?
From the normal distribution table. This table. Okay? This is a normal distribution table.
Yep.
This table, okay? Or you can just say from the table because the table is always given to you. All right. Any more questions? Go ahead. No, I'm not talking about this thing. Okay, that's good. I just want to make sure I'm not. Okay, that's good. But it already uses this to find this. Yeah. And this. Yeah. Okay. Wait, how did we get the 1.28? From the table?
Can you explain how we got to that figure? Because I know you were saying we use that 90%.
So this 19% is the one we're going to interpret this table, right? If you look in the table, this 19% is actually 0.9. Is that correct? So finding a number which is closer to 0.9, which is close to the 0.9.
Because of the 90%.
Yeah. So the 19% is 0.9, 18% is 0.8. So the closer one, pick the close one. I want to keep you guys easy, right?
Okay. So where did the 1.28 come from? If it was like
This is the 1.2 and this is the 8.
So that's how it works.
Yeah.
So if it was like the 80, then the 80 would be 1.27. It's the one before it. Listen, I'm just saying.
So if you have something, the probability is 18, is 89 percentages, then you are going to pick is the 1.23 here.
Okay.
Yeah, you got it. All right. So I guess that is a easy one. Let's try. So this question is regarding what is the probability that the duration will not exceed 22 days? So that means the duration less than the 23 days. Is that correct? So the question is, the duration is less than 23 days, and what is the probability for this? And then we have already given you how to determine the X, right? So your X is equal to your duration minus the mean divided by the stand. Is that correct? So you are getting 23 minus 22 divided by, what's the number for that one? 3.5. And you get x is equal to what? Tell me, x is equal to what? Point 2.8. Is that correct? 0.28. So if you know this is x is equal to 0.28, then you're going from the table. Okay, x is equal to 0.28 from this table. 2 is here, 8 is here, and you can draw a clear number here is 16.103, right? So this is your answer, okay? 16.103 percentages. Is that easy?
Yeah.
That's pretty easy, right? Okay, very straightforward with the equation, right?
Yeah.
Okay, so if we have a drawing or plot over here, then you will see x is 0.28, and that is this part. Does that make sense?
Yeah.
And this part is 61.05 percentages. All good?
Can you go back to the chart and explain that one more time?
So if you know your x is equal to 0.28, right? And this is 0.2, and this is 0.28. Okay? Yeah. Thank you. So now let's take a look about this question. Okay, let's make this, okay? So this is the last question we are going to do today. And I will posting the video recording to the Blackboard, okay? And then you have another 2 we will do on next week, okay? Yeah, is that okay?
Yeah.
Yeah, we learn 3 and then I'm going to assign to you for practice. Oh no, it's hard, okay? No, it's really different sense. So, okay, so we learn this is the 3rd one, and then we cut for today, and then next week we do another 2, right?
That's fine.
Okay, so let's take a look at this one. So let's read in. I know the last 2 is a really challenging one. So what is the probability that the duration will actually exceed 25 days? Exceed 25 days. The purpose 2 is always say no more than, not exceed, right? And the maximum duration is what? Then you are getting 19 percentages over here, right? But this one is say exceed. Exceed is more than, right? If more than is in the right side or the left side?
Right.
In the right side, right? So let's have this plot first. And we know the mean is 22, right? And now we have given a number is what? 25. So can we get in this part? So this part is the P of less than 25. And this part is from here to here. This part is the P is more than 25, right? So we're going to find the P more than 25, right? So P is more than 25, but we know P less than 25 plus P more than 25 is equal to 1, right? So that means we can get in this one from 1 minus P less than 25. Is that correct? Is that correct? So this part is this. The whole sense is 1. If you remove the yellow part, then the blue part is the one you're going to find. The blue part means it's more than 25. The P is probability, and the more than 25 is duration more than 25. Okay? I'm shorting this one. So does that make sense? Okay, so if that makes sense, we're going to finding is we need to know P less than 25. Does that make sense? Because we know using 1 minus this one, we can get it, right? So for P less than 25 is what? P less than 25 is this part, right? Is this yellow part? How to find this yellow part? We have we found the X first, right? So found X is equal to 25 minus 22 divided by 3.5 is equal to 0.80. Oh. Tell me the true number. 85 what? 71. Thank you. So we're getting this X is equal to this, right? Then you can run up to 0.18.6 because in the table we only have 1 decimal and 2 decimal place, right? Now you can find the P less than 25 from the table. Then you get a P is equal to what? 0.8 and then 6. 0.8 is here, and the 6 is here. Then you're getting this number is 18.51, right? And then you get 1851 is your P less than 25, right? So then you have this part is 1851. And how much is for this part? So you are using 1 minus this 1851, you're getting 19 something. That's all.
Where did you get the 20 from?
Getting what?
Where did you get the 20 from?
Which one?
25.
What is 20? We can only hear the half parts and we cannot hear the late half part. So are you mean where we get the 25, right?
No, where did you get the 25 minus 22? I don't know where 22.
What is 22?
Find X.
This 22 is the standard, is the mean. The mean is giving you at the beginning of the problem statement here. Does that make sense?
Yes.
Okay. We're still doing the same question. So, okay. All right. So that is the third question. It's only changed a little bit is because you're going to find something more than you can convert it to be less than something, right? So if you already understanding this one, take your moments looking the question 4 and 5, see if you can figure out it. Then we will do it next week, okay? Okay. Which one? Which formula? This one? No, this is no, I'm not a statics. No, this is a long time ago. So basically, let me see this. You have 5 red balls, you have 5 blue balls in the box. You put your hand in, you want to draw one out. What's the chance you get a red ball? What's the chance you get a blue ball?
1 out of 10.
It is 5 of 10, not 1 of 10, because you have 5.
Oh, yeah, 5 out of 10.
Yeah, basically it's half, right?
Yes.
You have chance to get a red ball, half chance to get a blue ball.
Yes.
And then this is the blue ball, and this is the red ball. Does that make sense?
So why is it 1 minus?
Well, minus the total together is 100%. You have half chance to get a red ball. You have 100 chance. Sorry, you have half chance to get a red ball. You have 100 chance getting a ball.